Good morning, good afternoon, and good evening, everyone, depending upon the location you are joining us. My name is Vikram Pol, your battery expert and representative at batteryline.com. Our first webinar regarding battery can manufacturing was a success, and it is currently available in batteryline.com's YouTube channel. Thank you so much for our audience joining us today for this highly anticipated webinar on Gigafactories, American cell manufacturing, and onshoring the supply chain to America. We would like to welcome today's expert, Mr. Paul Charles, who is the co-founder and former president and CEO of American Battery Factory. Paul is a senior executive and battery cell ecosystem thought leader focused on renewable energy technologies. Paul, we request you to share more of yourself to our audience.
Great. Vikram, thank you so much for the opportunity to spend time with you and your audience today, and to have Battery Line host the event here today. I've been commercializing technologies and really innovating new paths for the past 30 plus years in multiple sectors with this constant threat of energy. After leaving IBM, I started my own high-tech firm based in Silicon Valley, California in the United States. Along with Switzerland. I made all types of different peripherals or accessories for portable computer manufacturers, a very broad spectrum from battery chargers and auto adapters to docking stations to keypads and carrying cases. After 11 years, I took the company public and then started doing projects down in Mexico with the sovereign-owned energy entities down there. Before having an opportunity to come up here to Utah, still in the United States, to help commercialize a remarkable nanotechnology breakthrough in converting greenhouse gases into selectable nanocarbons, specifically carbon nanotubes and carbon black with only distilled water as a byproduct. That was a several-year venture in stealth mode before I exited. I was then introduced to a company here in Utah that makes energy storage products, and they asked me to set up a gigafactory to make LFP or lithium iron phosphate prismatic cells for energy storage applications specifically. Now, nobody had ever done that before in America. There was no precedence, there was no roadmap, there's no supply chain, but I'm always passionate about doing things which are challenging. So 24 months later, after that initial challenge, the governor of Arizona and myself announced a $1.2 billion gigafactory. And this was really the first in a whole network of clean and green, rapid construction modular gigafactories, while also initiating the onshoring of the entire supply chain for that specific type of battery. I created a blue chip consortium of trade and financial partners, which really allowed this to make this possible, frankly. The journey was pretty remarkable and actually truly inspired as well too. This year, I left American Battery Factory, the company I co-founded and was the first CEO and president of. My focus now is really on a global basis and helping people all over the world become energy independent as a global gigafactory supply chain and renewable energy advisor and expert.
Thank you so much, Paul, for that inspiring introduction. Without taking much time, let's begin with today's webinar with the following Q&A session. So the first question to you, Paul, is what makes USA a desirable destination to set up a cell factory or cell gigafactory? What are the key factors, according to you, that have contributed to the growth of cell manufacturing in the USA over the past few years?
Great question, by the way. Well, there's certainly a high degree of interest in setting up factories here in the U.S. and in North America. About 2/3 of the gigafactories in Europe are actually on hold, is what I've been reading, because they're doing analysis in terms of really how good is the incentives in the United States to stand up factories there initially before going to other places in the world. But I'm going to talk essentially about 3 different areas that really create a wonderful environment to stand up factories here. One's the demand, the next is obviously the government incentives and access to capital, and then the third is really kind of this innovative ecosystem that we have here. So let's first talk about the demand. Well, first of all, what I can say is it's absolutely massive here in the US. Between the electric vehicle demand, energy storage, and other e-mobility sector demands, it's off the charts. Now, do keep in mind the U.S. is kind of like a fresh palette. You know, if you're an artist here, it allows us an opportunity to create something which really hasn't been created before. Asia has had 15 plus years to really create and shape and to scale Gigafactories production and things along that line. And Europe really hasn't been that far behind as well, too. So let's chat about the government incentives and access to capital. There's tax provisions, there's grants, there's loans, there's rebates. There's a host of different types of financial capabilities and offerings in the marketplace, and they can be challenging to navigate. Just at a very high level, the United States in general provides post-performance financial incentives. So after you actually make something, that's when it gets really lucrative. And I'll talk about that in a couple minutes here. Now, China, on the other hand, has both front end as well as back end funding in which they really create and encourage an entire ecosystem in one geographic location. It may be in a city, but it may be regionally as well, too. They really have been able to create a template which is unlike any place in the world. Europe in general has been able to provide incentives more on the front end. But once again, each area has their pros and cons. There's no doubt about that. So in the US, I'm going to talk about three different types of financial incentives. One's the IRA, the other is the Infrastructure Act, and the third is the Defense Production Act. So let's first talk about the Inflation Reduction Act, or as it's known as the IRA. It's $370 billion worth of incentives. And this act was passed about a year ago and signed into law by the president. And in general, this really focuses on manufacturing incentives and providing something which is called a production tax credit, or a PTC. And to let you know how lucrative and how positive this is, it's $35 for each kilowatt of battery cells that you produce on that. Once again, post-performance. So to give some context to that, on a 300 amp hour prismatic cell, frankly, it doesn't make a difference in terms of the form factor. You're able to get $33.60 for every cell that comes off the line. Now, that's at the cell level. If you look at the module level, which is as it starts to integrate the cells into the module, you add another $10. So if you're at that particular level, you got $45 per kilowatt. The third aspect of that is you're also able to get 10% of cost of goods for mineral extraction and processing. So let me give you some examples on this. So in a small gigafactory, let's say 3 gigawatts, on an annualized basis of production of that level of cell output, you're able to receive $105 million of production tax credits. So in a 30 gigawatt facility, you're getting over $1 billion of production tax credits every year. So you take a step back and you look at the CapEx, the capital expense costs associated with this. In about a 3 to 4 year time frame, you're literally able to get your entire CapEx costs back simply through these production tax credits, which is simply unprecedented. Like I said, I've been doing this for decades, and I've never ever seen this type of incentive on this. It's really probably been since World War II, since there's been such an incredible outpouring of support at the government level, multiple government levels, and we'll get to that in a moment. Okay, so the second area is really the Bipartisan Infrastructure Act, and I actually had an opportunity to help craft or shape that in a little way by providing amendment suggestions for that. So the Infrastructure Act, it's really geared on the upstream sector of the supply chain, and this is mining, extraction, and processing, which certainly needs help and assistance. Last year, about $2.8 billion of grant monies were distributed amongst a couple dozen companies, and there's over $3 billion in additional funding still available. And keep in mind, these grants, these are matching dollars, okay? So you got to come up with whatever the allocation is, whether it's 20 million or whether it's a couple hundred million. There's also been some interesting things that have happened, since those allocations were announced. A couple of the dollars, one was almost $200 million, was pulled back because of the ownership position that was discovered from a Chinese perspective with that. Another area that we should chat about briefly is called, within the Department of Energy's sector, and it's the LPO, the Loan Processing Office. And they literally have hundreds of billions of dollars available in loan guarantees. But here's the challenge. It's a 2+ year cycle time right now. And the last that I was told verbally, it's probably close to $100 billion of backlog. So if you want to have these loan guarantees, get in line, buddy, because it's going to take some time in order to get these done. But some of them have been pretty substantial. I think the latest that I read was $8 or $9 billion in terms of loan guarantees, with one opportunity with one company alone. The third, the Defense Production Act, those dollars essentially flow into the IRA. So we've kind of already chatted about that. And then one area that not many people really talk about is the incentives at the state level, the county level, and the municipal or city level, and the utility level as well too. When I announced the governor of Arizona and myself announced the $1.2 billion Gigafactory last year, we also announced $240 million of incentives just at that state level. So multiple levels, multiple ways in order to able to help this whole process along. And the local utility was fabulous as well too. They actually provided grant dollars, not matching, grant dollars to help set up the substations and to upgrade the power and the utilities which are necessary. And the third thing that we'll chat briefly about is the innovation and this collaborative ecosystem that really is remarkable here in the U.S. We have an opportunity to work with both state-sponsored laboratories along with private laboratories that are in universities, for instance, or truly in the corporate sector, to be able to joint venture, to license, to have a cooperative environment. There's incredible technologies here in the U.S. that need to get out in the marketplace. And one of the challenges they have, frankly, is they'll get to a certain level, and that's it. They just literally have to stop, because that next step is to go into a gigafactory. And since we have very few gigafactories here in the U.S., and even fewer that are willing to test or adapt or do dry runs or pilot runs with new technologies, it can be a challenging environment. However, the new technology is absolutely here. Keep in mind that a lot of the chemistries were originally developed here in the U.S. as well as in Japan before being sent abroad, particularly to China.
Thanks, Paul, for that very detailed explanation about what makes USA a desirable destination for setting up a cell factory, and also giving detailed explanation about the incentives provided by the government, that is the IRA, then the Infrastructure Act, and the Department of Energy. Coming to the next question, now that we have discussed the benefits, what makes it desirable destination, can you mention some challenges that the gigafactories face while setting up in USA?
I'm not sure if we have enough time today and tomorrow and next week on this, but I will mention a few, okay?
Okay.
High level, everything's a challenge. It's the wild, wild west here, okay?
Mhm.
Everything is new in terms of being able to scale up. The positive thing is that we have a truly unique position. As I mentioned, Asia, particularly, China has had 15 plus years to figure out what works and what doesn't from the scaling perspective. And then Europe has also had many years to perfect this. So we're in a unique position to look at the rest of the world and say, what's worked and what hasn't, and then how do we improve upon that as well? Okay. I'm going to talk about several different things that are challenging, and some are difficult to chat about. And the first one really is the geopolitical situation with China. At the federal levels, the sovereign levels at both countries, it's a very dynamic and very fluid environment, is the politically correct way to state that. And it causes great angst and concern on both sides, particularly in the private sector as well too. Um, if at the federal level, you've got senators that are actively, asking for email information and really trying to understand the details associated with these relationships between Chinese companies and the U.S. companies. A great example of that is the recent, announced last year, I believe it was, with Ford and CATL. It's a $3.5 billion gigafactory that they're going to be putting up here in the U.S. And when the idea first came out, they obviously went to multiple states. And it was interesting because the governor of Virginia literally said, "Hey, you know what? Don't even count us in terms of one of the potential locations because we don't want to have the Chinese here." And that was in Virginia. In stark contrast to that, you had the governor of Michigan raising their hand, going, "Hey, come on over. We'd love to have you here. This is a very positive situation for the state. How can we help and to assist?" And so at the state levels, it can be very diverse in terms of support at the county level and even at the city level as well too. So all I can say from that situation on that is the business models are being created and are evolving. What we know so far of the Ford and CATL model is that there's a licensing structure that's being put into place in which CATL is licensing the technology of manufacturing the cells and scaling the cells to Ford Motor Company. So we'll see if that model will continue to be approved, or if there's a different model or models that'll be accepted at the government levels. A second thing we ought to chat about is the trained workforce. I'm telling you, it's probably one of the most difficult and most challenging aspects of standing up a gigafactory that not that many people are actually even talking about. If you think about the locations where the typical gigafactory is stood up, it's not in the city. Okay, these locations typically require hundreds, sometimes thousands of acres. So simply by their nature, they're going to be in a rural environment. Well, in rural environments, you typically don't have that many people, particularly trained people in a specific technology sector. You don't have adequate housing for thousands of people. You don't have school systems. You don't have grocery stores. You literally almost have to have an environment in which it's a new city. Okay,
Mhm.
and so that's an absolute challenge associated with that. And then if you look at another aspect of that, is those areas such as Reno, Nevada, where Tesla had stood up their first gigafactory. There's massive competition for the workforce. And so the cost of labor goes up considerably. The whole idea is like, well, if I don't want to work here, I'll work at this one over here, because Reno's obviously a really good place. We'll probably chat in a little bit also about where the gigafactories are going up as well too. I do want to mention a couple ways in which I overcame or mitigated the risk with the workforce situation. One is that I took the lead from somebody that I greatly respect, and that's Jenny Rometty. And she's the former president and CEO of IBM. And essentially what she did within IBM is she eliminated the requirement for college degrees for most of the jobs at IBM. That was a groundbreaking decision that she made, and it really inspired me to make those same types of decisions as well. Obviously, there are some types of work, particularly in the R&D sector, where you need a PhD, okay? But in order to run some of these automated pieces of equipment, you don't need a 4-year degree. And not everybody has had an opportunity, frankly, to do that. Jenny had actually told me about 70% of the people that they hired that did not have degrees eventually went on and got their degrees. So that in itself allows us to open up the realm of potential candidates considerably. Another thing that I did is I partnered with local tech schools so that they could train a local workforce in a continuous manner. You work with them and create a syllabus and a training course. So whether it's a 3-month program or a year program, whatever is appropriate, they can literally train your people so when they get out, they're ready to go into the factory and are familiar with the software and the hardware and just the whole interface of how to run these gigafactories. And by the way, I did that no cost to us. as a company, and that cost was picked up at the state level. So pretty cool. One final thing I'll mention on that, in terms of the workforce, is to look for areas in which there's a decent sized base of people. MSAs is what they call those here in the US. And I look for million plus or more, but also areas that really didn't have many gigafactories in the area, so you weren't in competition for the workforce. Third area I'd like to chat about is really the equipment. That is very, very challenging, and I think appropriate to the conversation on some of the audience today. About 80% of the anticipated battery manufacturing capacity still has to be built. So there's a lot of equipment that still needs to be built. And keep in mind, this is a very young, very nascent industry. The lead times can be extremely long. And this is a quick side note. One of the manufacturers that I've dealt with over the years, they had requests for over 200 lines just from one country alone. So to be able to develop a relationship with a good quality equipment manufacturer in and of itself is a great accomplishment. And for them to accept the opportunity to work together is a whole nother level. Just because you have a demand doesn't necessarily mean it's going to be met. And it does not indicate it's going to be met in a short time as well, too. In the U.S., there's, as far as I know, and I've spent the last several years on this, I don't know of any gigawatt level cell equipment manufacturers that provide a complete turnkey solution in the U.S. It simply doesn't exist. Really, you have to go to China for that complete turnkey solution. Japan, as well as Korea and Germany, work together sometimes, but oftentimes here's one equipment manufacturer that does one specific piece of equipment with that. Another aspect of that that needs to be considered is if you do buy your equipment from China, and if you're in the U.S., you're going to be paying some mighty hefty tariffs, 25, 28%. And so once you add that in, you're up to the costs of some of these other countries as well, too. So you have to look at the whole experience, and when you do order and when you do work with the equipment manufacturers. I do want to mention that one thing that's absolutely critical is to have on-site support. If you have a gigafactory, you better have spare parts. You better have people that absolutely understand all the nuances associated with this, because you do not want to have your gigafactory go on hold or have to stop. That is a worst case scenario, to say the least. The fourth area I want to talk about is delays. I don't know of a single gigafactory off the top of my head here that has not announced or experienced some type of delay. That's just what's happening here. And so we need to learn from these examples and learn from these experiences so we can at least reduce or mitigate these delays as well, too. A fifth area is a site selection. I spent over a year personally looking at sites all across the U.S., and it can be very challenging. The number one challenge I had, frankly, was power. The Gigafactory, even starting out at a low level, you're going to need at least 20 megawatts, and we're going up to 125 megawatts. That's a lot of power. It really, really is. I had some areas that said, "Oh, no problem, we'll get it to you in time," and I question them on that, because the lead time on transformers as well as substation componentry can be years out there. So from my perspective, that's one thing the states, the counties, the cities can do and be proactive, is to bring power to an area and really create an ideal environment for a gigafactory. Community support is absolutely critical. If you don't have that, you're going to have a challenge. In this past year, there was an announcement with a large gigafactory in Arizona, and the announcement and the location was literally physically across the street from a residential area. And let me tell you, the residents were not happy, okay? And they went to the news, went to the TV, and really voiced their opinion about that. So from my perspective, you got to work with those community leaders, and if you don't have that support, find another location. You don't want to have a tense and adversarial relationship with those people that work around you for a host of different reasons. But going back to the workforce, that obviously affects that as well, too. The infrastructure and connectivity is absolutely critical. So you need to be able to find a location that has access to rail, to roads, airport, and things of that nature as well. So once again, these locations that are out in the middle of nowhere, it can be very, very challenging to say the least. Just a couple more things, and then we can go on to the next question here. Supply chain is also a massive issue. The proximity of that, and frankly, just the availability of even having the materials here in the U.S. As a quick side note, just on the mining side, it's an average of over 10 years to get permitting and the ability to even uh, move forward with a mining situation. This last year, I was out at one of the largest lithium in-ground lithium supplies in the world. Talking with the people there, and they showed me the list of all the litigation they had. It went on for pages and pages and pages. I mean, literally a dozen years of litigation. And so it's very challenging to stand up new mines. Just recently, at the federal level, they were able to make some alterations in terms of the transmission capabilities and other things relative to this. And so we hope it'll get better because it certainly has been very, very challenging on this. And the concept of not in my backyard mentality. Well, we got to have mines, we got to have this, but just not next to me. Okay, we've got to change that. This is not the 1950s and 1940s. We actually do have access to technologies which allow us to have clean and green and sustainable ESG friendly environments in the mining sector with this as well. And then last thing relative to that I will mention is on the supply chain, we got to build trust. And that's for the entire supply chain. We need to be able to be very open with our data, what's working, what's not, any changes or so, because it'll help everybody in the supply chain, everybody in the ecosystem to have a better product at the end of the day. Three more things I'll mention, and we can kind of go on, is that the capital associated with standing up these gigafactories, it's an issue. It's a big, big amount of money. In general, it's at least $100 million per gigawatt. So in general, you're talking billions of dollars. These are not easy, to create these types of environments with this, and it's just a lot of capex. Also, the lack of experienced individuals here in the U.S. that deal with gigafactories. There's very few, is the bottom line. And the last thing I'll mention is the public trust. Once again, it goes back to whether at the community level, at the state level, at the federal level, trust has to be created.
Yeah, thanks, Paul, for mentioning the challenges while setting up a gigafactory. And thanks for giving a detailed explanation about challenges faced in workforce, equipment manufacturer, site selection, and supply chain, and on raising capital. So that's a very good explanation about the challenges. Yeah. Coming to the next question, what are the typical output capacities of gigafactories being planned in the USA and reasoning behind those capacities?
Thank you. And this continues to evolve. In general, you really want to look at the economies of scale. If you go too small, you just can't be cost competitive. All right. But even on the other end of the spectrum, if you get too large, you're going to have supply chain constraint issues. You're going to have workforce issues. But to be specific and to answer your question, I really don't suggest anything smaller than 3 gigawatts. What we're seeing now is really that being migrated to about 10 gigawatts, excuse me. So 3 gigawatts growing to a 10 gigawatt level. Really, that's the minimum size that you really would want to consider with that. It also gives you an opportunity to be able to flush out challenges, issues, to be able to get your workforce better trained, and to make sure all the parts and pieces are working together. And to put things in context with this as well, too, a 50 gigawatt cell factory should be able to produce enough cells for about 1 million EVs. So we absolutely need to have a tremendous amount of capacity here in the U.S. The largest gigafactory that I know as a standalone is about 140 gigawatts planned. The sweet spot seems to be in this 30 to 40, maybe 50 gigawatt level. And keep in mind, these are multiple lines that are going into that as well. You also have announcements with particularly large EV manufacturers that are putting up multiple factories and really want to achieve at least a couple hundred gigawatts of annualized capacity. And in terms of kind of the reasonings on this as well, um, the key focus is really to create enough cell capacity for their own internal use. That's the number one driver. Very few, frankly, have this perspective of, oh, I'll then provide it into the marketplace. It's really for their own use. And so as they project what their needs are, that'll be the controlling factor in terms of the size of the gigafactories and the number of gigafactories as well too. Obviously, we've learned through the COVID experience that the control of the supply chain is absolutely important, and they got to be able to keep their cost of goods in line associated with that as well. Some areas you may be constrained is with some of the site utilities and power and things of that nature we talked with earlier. So there may be size constraints associated with that. Also on the infrastructure, there may be limitations associated with that as well too. I do want to mention in terms of the areas that have really been able to blossom and show the rest of the U.S. how you can attract and retain gigafactories, and what we call that is the battery belt. So it's the Midwest and the South essentially. There's a couple exceptions with Tesla out in California, and then Texas is a part of this as well. But there's a half a dozen states or so that have done a phenomenal job in attracting gigafactories in many different levels with that. Some states, and I've dealt with them personally as well too, literally, it seems as though they don't even care if the gigafactory comes. They offer zero incentives, but those that do can be very aggressive and very much have a partnering spirit.
Yeah, thank you, Paul, for that answer. Coming to the next question, how can partnerships and collaborations add value for scaling up the giga scale production on the giga scale?
And once again, this is my opinion here, but I think partnerships are absolutely essential with few exceptions, okay? And that can mean the difference between success and failure of the output and being able to scale a successful gigafactory on this. And it can mean the difference between 2 or 3 years and 4 or 5 or 6 or 7 years in order to have a gigafactory that's up, that has stable production levels and yields which are profitable to say the least. From a philosophical perspective, it's kind of interesting. It's over 70% of the gigafactories in the U.S. are built by EV manufacturers, either by themselves, quote unquote, or with a technology partner. In China, it's the opposite. It's actually 80% plus of the capacity that's really driven by the battery manufacturers themselves. So once again, this is more of a business philosophy, but it's interesting to note that Europe is more along the line of China. As I mentioned in my introduction, I created this blue chip trade and finance partnership consortium. And I did that with a process, or what we ended up calling a strategic teaming agreements. And let me describe half a dozen or so different categories in which I think partnering is critical, at least it was for me. One is to get the right financial partner. I was able to engage with the number one ESG investment banking company, and they really knew the space. Absolute experts, didn't have to explain to them the ins and outs associated with this. They have current as well as former success in the space there as well. Second is the automation partner. That's the software, the hardware, and the battery analytics side on that as well too. You do not want to stand up a factory in the U.S. that is heavy on the labor side. You want automation, and for a whole host of reasons associated with that. And you better find a really good partner that understands that, that's dynamic, and it's has flexibility and is constantly improving their products. Next is the supply chain from a logistics perspective. It takes a lot of know-how, a lot of capability to facilitate the raw materials. In the prismatic high-capacity LFP cells that I had been focusing on, there's a couple dozen different components. It may sound like, oh, it's just a couple dozen and it's not thousands compared to an automobile. It still takes a lot of effort, a lot of know-how, and a lot of working capital to make sure that you have the proper amount of raw materials at the right location, and it arrives at the time that it's absolutely needed with that. Another partner that is vital is an EPC, which is the engineering, procurement, and construction partner. I was able to engage with one of the world's largest, and so whether I wanted to put up a factory in, one state or a different country around the world, they were able to do that. So an EPC partner is part of the mix as well. The building technology. I utilized a very advanced and very unique building technology, which allowed me to have a rapid construction approach. I could literally stand up buildings in 6 months, anywhere in the world. That were airtight and a third the cost of traditional construction, at least by U.S. standards. That was very important as part of my overall approach to, let's look at the rest of the world, but let's also take an American approach to this. Cell equipment manufacturer. We've chatted a little bit about that already. Absolutely critical in terms of partnership with that. If you want to make sure that your products are going to be, functioning properly, that you're going to be able to increase your output with that, the equipment manufacturer is absolutely a critical component of that, especially as you're standing up factories and testing them in country before you then pack them up, put them on a boat, and send them to the U.S. or wherever it may go to. Also to have a technology partner, and it may be plural relative to that. You may have that in-house in terms of cell designs, bill of materials, and things of that nature, but to have partners that are really innovative but also pragmatic, I think is absolutely important. Bill of materials suppliers kind of broken up in two different categories. One are the direct suppliers of the raw materials that you need to have, and then the second aspect of that is relationships that you can establish so you can license the technology. For instance, in cathode production, you can license the technology of that, or you can partner up with a supply chain. Some of the raw materials, it's better to go with a partner rather than license or try to figure it out with yourself on that. In terms of partnerships, I'd mentioned briefly about the workforce side, but teaming up with the local tech schools, I think, is absolutely important with that, and also local groups. One thing I did is I reached out to the local veterans groups, because you have a number of people in the U.S. that have been in the military. Some of them have retired after 20 years. Incredible skill sets, know how to work in challenging environments, and they're looking for their next career. So to be able to have an opportunity to partner up with people that understand how to work in the challenging locations around the world can be a wonderful wonderful opportunity to really partner up. And then those educational institutions as well too. I've really found that to be a delightful environment when you can partner up with a local university or junior college or even at a high school level and develop apprenticeship programs. And this was something that I'd learned in Switzerland. I had an office there for a number of years, and their apprenticeship program was quite impressive, to say the least. And then also to have interns come in from multiple educational institutions. Great opportunity for them, but also a wonderful resource for the company as well, because sometimes people don't know enough to say, oh, we can't do that. They just jump in and figure out new ways to do things. So it's kind of cool from that perspective. And then also to partner up with the national private labs that I'd kind of mentioned earlier as well.
Yeah, thanks, Paul, for this explanation about how partnerships helps in building up gigafactories, and thanks for explanation in detail about finance partners and automation partnerships and supply chain partnerships. Coming to the next question, since we are in the digital era and era of AI, what is the role of digitalization and creating digital twins while setting up cell gigafactories, according to you?
Yeah. Once again, that's a whole other area that I'm very much of a proponent of. That this digitization process and digital twins. It's really kind of like essentially Industry 4.0 or the fourth industrial revolution, right? In which we're using artificial intelligence, we're using machine learning, we're using all kinds of different automated pieces of equipment and both hardware and software that connect throughout the entire supply chain as well as the manufacturing process of that. I'm very much a proponent of this. From my perspective, the more data we have, the better, and it allows us to create better efficiencies, better quality, better flexibility on this. With digital twins, just think about it: the opportunity to actually create an entire factory in a virtual realm and then to simulate different experiences throughout that, the what if scenarios, is really kind of unprecedented until recent times here, and it allows you to really optimize your resources in so many different ways. You can identify process flow and material handling the bottlenecks and power draws as well too, because you're able to dial down into an area that gives you a lot of detail that once again you never really would have understood some of this stuff unless you actually have the factory up and going. It allows you to place your equipment properly as well too. There may be everything from height constraints to temperature issues, environmental issues with that, all the way down to the foundation. How much concrete do you need to have in order to support some of these very large and very heavy pieces of equipment that you may not even have considered. It also reduces the cost to literally go vertical with your building, assuming you have a greenfield site, because you're going to have fewer change orders because once again you can create all this in a virtual world. The preventative maintenance aspect of this can really not be overstated as well too, because you can see how often these pieces of machinery are running and at what level, what volume, and as you increase output as well, how that's going to affect the maintenance schedule associated with this. And then also the training and the education aspect. You much rather have somebody play in a virtual world as opposed to these pieces of machinery that are millions of dollars. We want them to learn how to utilize the resources and the tools that they have in a virtual setting, so you're not going to cause problems or issues. On the purely digital side of this, the opportunity to have real-time feedback is once again is unprecedented. We have an opportunity as we stand up these new factories to have data that we can then not just collect, but we can also interpret as well too. So that predictive maintenance that I talked about earlier on that, there's preventative, but there's also the predictive aspect of that is pretty important. Mm-hmm. The supply chain management aspect of that, to know how much inventory can be stored on site and how it should be flowed in, the demand forecast and things of that nature. And ultimately that leads to quality control. If you can have better quality control with your inputs, you're going to have a better quality control, on the output as well.
Yeah, thanks, Paul. Coming to the next question, how is USA fostering a skilled workforce to support the growth of cell manufacturing and to ensure a sustainable talent pool for the future?
Oh, I'm sorry. Could you please repeat that one more time?
Yeah, no problem. So how is the USA fostering the skilled workforce to support the growth of cell manufacturing and to ensure a sustainable talent pool for the future?
Got it. Understood on that. Well, first of all, I guess I can ask a question back. Who says they are? Okay. I mean, it's one of the challenges that we've talked about here today. The trained and skilled workforce is one of the top issues associated with this. And I'd gone through some of the challenges associated with the location of the gigafactories, being in rural environments and things of that nature. And those areas that have become popular, then you're in a competitive environment, with this. And so I'm a strong believer, once again, in establishing apprenticeships, also eliminating the need for college degrees, and being in areas that have a larger number of people, but you're not in a competitive environment in terms of the number of gigafactories that are in your area.
Okay. Yeah, thanks, Paul. When it comes to, we would like to add some points over here as batteryline.com. So when it comes to career opportunities, our community members here at batteryline.com have started to share exciting roles and opportunities. So I request whoever is finding uh, who are finding opportunities, please visit the job section, and there you will find the opportunities to apply for jobs. So coming to the next question, are there equipment related challenges that arise when transitioning from research or pilot scale to commercial or giga scale manufacturing in the US?
Um, Absolutely. One thing that I've certainly noticed and have lived through is just because you can do something at a lab level, at a bench level, really does there's no guarantee you can do it at a large commercially scalable level. With that, you can learn a lot of things. There's no doubt about that. But I've been involved in commercialization projects that should have taken a couple of years and they end up taking years. I've been involved in other projects that you simply couldn't do it from a technology perspective, or just because you needed to have a new discovery that did not occur. So it's great that you can do it at a small level, and if you can have experiences where you only have a certain number of x times increase in terms of the output, you can certainly learn from that. But to go from a bench to a high volume gigawatt level capacity output is absolutely challenging. There's no doubt about that, and there's multiple things which really play into this. Oftentimes, you're going to need a new design, okay, because the volume that you will put through with a gigafactory, and in general, the mentality needs to be these run 24/7. In reality, they actually don't run 24/7 because you need to have the ability to maintain this. Because if you don't maintain it, you're going to be in a line down situation with this. But the equipment needs to be designed to be able to run 24/7 for many, many, many years to come on that. So larger volumes of materials along with higher production rates absolutely have to be a key part of the design of these larger pieces of equipment. And then also just the ability uh, to pull your tolerances in, shall we say, on this, because if you're at a pilot level or a small level, you can have small, perhaps insignificant changes in the materials, for instance, or just in the tolerance levels of the pieces of the components that go into the machinery. But those get exaggerated as you go much larger. So your tolerance capabilities and your control capabilities actually have to be tighter at that particular level as well, too. Material compatibility is another issue associated with this as well, because materials can act differently in large volume. They can act differently at large scale versus small scale, and also different environmental situations, the heat, the humidity, the chemical reactions, and how they all interplay with this. So these are things that you don't know until you actually have a chance to scale with that. The reliability aspect, you better have a very robust maintenance and monitoring protocols associated with this. And as a quick side note, that's actually one of the challenging positions to fill in a gigafactory, is to be able to find people that are willing and skilled and conscientious enough to do a great job on the maintenance side, both in a preventive as well as a proactive mode with this. The automation side of this as well, the type of automation technologies you have in a pilot plant, vastly different than at a gigawatt level facility as well. And cost constraints as well. The capex associated with this, as we had mentioned earlier, is very significant to say the least. I could go on, but I think I gives a fairly good overview of some of the things that you'd wanted me to chat about.
Yeah. Paul, I request you here that can you speak more about what will be the challenges on the automation side of while expanding the factory, like from going from pilot to giga?
Yeah, in terms of on the automation aspect of this, one of the key challenges that you oftentimes can see is that the pieces of equipment have to all talk together. Okay, and we didn't really chat much about this, but on a manufacturing side, from the equipment perspective, China is one of the few countries in the world that has a turnkey solution, and there's pros and cons associated with that. One aspect of that is it's a lot easier for cell manufacturers to just have one contact, one interaction, as opposed to if they're dealing with a dozen different suppliers. If there's a challenge, if you have multiple suppliers, oftentimes you'll get one equipment supplier say, "Oh, it's not my issue; it's that issue." Okay, it's their problem. If you've got one contact in a turnkey environment, it's their responsibility, it's their role. They can definitely figure that out. But the connectivity is super, super important. With the MES software overlays on this, the ability to have that type of coordination at a pilot level. Typically, they don't put that time and effort and have those types of capability at the pilot level. At a gigawatt level facility, you absolutely need to have that as well. And I really believe that as we can learn to connect in with these pieces of machinery, once again, we're going to have better data. It's going to be a much better product at the end of the day with that. One thing I would like to see is at the smaller scale is if they can start to learn to be more integrated, with the MES systems as well. I think that'll help from many different aspects, and particularly in the R&D sector, there to be able to translate the things you do in R&D on over into a production environment.
Okay, thanks, Paul, for that answer. Coming to the next question. So, why battery makers initially, while setting up their factories, tend to go for turnkey solutions instead of standalone?
You know what? That's we alluded a little bit to that. At the end of the day, it's easier. Okay, I mean, I'm not sure how to explain it any more than that. If you have incredibly skilled and talented people that are part of standing up a gigafactory and have experience with different types of pieces of machinery and the nuances associated with that, and you've got the support staff, then yeah, go ahead and order the best of the best from a dozen different suppliers with that. But there are so many challenges just to get this thing out of the ground and get it calibrated to reduce your scrap rates and get your yields to where they need to have. The easy route tends to be where people go with that. I would strongly suggest, though, that the companies that do produce a piece of equipment or multiple pieces of equipment, align yourselves with other equipment manufacturers and do provide an opportunity into the marketplace where you have a key single contact point with that. So that way you've got an option versus just going in and getting the turnkey solution, which in all reality, you're probably not getting the highest and best quality pieces of equipment across the entire line, okay? Because you have that turnkey approach, right? Versus, having an opportunity to work with a group, a coalition, a company that specializes in pulling in the best of the best pieces, and they are your key single interface associated with that. And so if there is a problem, you're not going to get this pushback. Oh, no, it wasn't me. It was somebody else that that contributed to that before it actually got to me. That is the last thing that anybody wants to have to hear or deal with on that. So those are some of my thoughts, relative to that area. One thing I do want to mention, though, is on the factory acceptance testing, the FAT testing that occurs in country. If you've got multiple countries that are supplying the equipment, that can be a challenge because ideally you want to be able to have your factory stood up and to be able to run something in a simulated mode before it gets all packaged up and gets sent over. I've talked specifically to companies here in the U.S. that literally forego that because the demand and the need is so strong that they'll say, just send it over here, do the best you can, and we'll figure it out when we get here. Well, that can work, and it can also work work for you, but it also can work against you relative to that. So these are some challenges that I think can be worked out so long as they're understood and identified up front.
Okay. So in context of regulatory compliance, what should be considered when selecting and implementing cell manufacturing equipment in the USA?
Yeah, in terms of some of the things that you want to do, the first and foremost is what I'd recommend is build a very safe product, period. Okay. Because I know the interactions that I did with China, Japan, Korea, Germany, as well as India, as well as in the U.S. here. Having a product that was designed with safety in mind was extremely important relative to that. In terms of the safety standards on this, UL is something that you need to have. And oftentimes when you ask for that, it can add 3 to 6 or more months to the delivery time frame associated with machinery. And so, at the end of the day here, you've got to be able to figure out what's important to you and ways in which you can help to mitigate some of those potential risks associated with that. But UL, I think, is very, very important. You want to make sure, and that's Underwriters Laboratory, obviously, and they have standards that are published and easily available on a global basis. You also have OSHA, which is the Occupational Safety and Health Administration. You have the National Fire Protection Association as well, too. Once again, just safety, safety, safety. The last thing you want to be is to be the headline news in the press where there's a fire at the cell factory that just went up there. You'll never live that down. So just make sure from a safety perspective, it's super important that you abide by those guidelines. Also from the environmental perspective, I'm a huge proponent of let's get rid of these nasty things that we don't have to use, okay? If there's solvents, if there's binders, if there's types of things which there are alternatives, let's utilize them, okay? And if we do that in designing those up front, then we're going to be able to make a huge leap forward with that. Nobody wants to have a gigafactory in their backyard if there's going to be contamination into the water table or going up into the atmosphere with that. So design your products in a way that you'll have minimal admittance, and in particular, make sure that they're closed loop systems associated with this as well. I'd mentioned lead times a couple times on this, and they can be substantial. So the closer relationship you can have with your equipment manufacturer, frankly, the better lead times you're going to have, okay? It can easily be years out, or they can be less than a year, depending upon what type of a relationship that you have, with this. The other thing on the safety aspect is, once again, going back to that data collection. If indeed there is a problem, if indeed there is an issue, you're able to identify this is what the root cause is, and you're able to fix that very quickly, or even better yet, you're able to anticipate that there would be a problem on that. So you utilize the great, incredible technical capabilities that we have now, as well as AI.
Yeah, thank you very much, Paul, for giving a detailed explanation about the regulatory aspects of battery manufacturing. So, coming to the next question, what word of advice would you like to share with machine builders, or it can be line integrators and solution providers, so that they can assist in scaling up gigafactories in America?
Wonderful question, and thank you for that. Quality. Just because somebody's got the lowest cost price, that's not the whole picture. Okay, you got to look at the total cost of ownership, and if you have a quality product that you've developed, make sure you have your case studies that show. Look at here's the impact of not having a line down situation. Here's the impact of having a quality product in the marketplace. That'd be the number one thing I'd suggest. Next thing is partner up. Is to work with other groups that have other pieces of equipment or other pieces of software in a collaborative mode here, so that you can provide an easier, more of a turnkey solution into the marketplace with that. And as this market evolves, the pieces of equipment will also be, I believe, be upgraded and be enhanced, and there'll be more knowledge base so that you'll be able to, have better, opportunities in the marketplace as well too. On-site support. Okay, you don't want to have a situation in which you've got a problem with a part, you have a piece of software that has issues, and you've got to wait for an office to open somewhere in the world. You don't want to have that. So when you stand up your Gigafactory, make sure you've got commitment for on-site support. for repair, for maintenance, the whole spectrum associated with that. It makes all the difference in the world with that. Also, the ability on the data analytics side. Once again, a huge proponent of collect as much data as you possibly can, and then take that data and actually do something with it, make it actionable. We're kind of in this environment right now where people are saying, okay, yeah, I'm collecting data, but it's kind of like a doctor where you go in and they may check your height and your weight, and that's about it. But you really want to be able to go in and get that EKG, right? Where you've got all this data of charging, discharging, much more data than you'd ever had in the past. It gives you the ability to once again define this and predict root cause issues and to have a better quality product overall associated with that. Also, once again, design your products to not have toxic materials in that, and listen to your customers. It's the basics of business on that. Sit down with them and really understand what their objectives are, what their challenges are, and how you can partner up and create innovative solutions in the marketplace on that. They'll be your best, your biggest and best, promoters if you bring them in and are open and once again develop this environment of trust.
Yeah, thank you, Paul, for that detailed explanation about and giving advice to machine builders and line integrators. Hope they are listening to this. And yeah, so coming to the last question of this webinar, how do you see the future of cell manufacturing in the US?
Very bright. I don't know how else to explain it. There will be opportunities for decades to come for those that get in now and are able to support the system and be collaborative and be innovative, but very, very bright.
So here we have come to the end of the webinar. Thank you, Paul, for taking out time and participating in our webinar. And thanks for your support to batteryland.com through sharing knowledge and expertise, which ultimately contributes to a greener impact. So we hope this webinar has sparked your interest and provided valuable insights into the exciting journey that lies ahead for cell manufacturing in the USA. So if you have any further questions or would like to continue discussion with Paul, please feel free to reach out to us at info@batteryline.com. Please follow us at batteryline.com to get regular updates about our community and also our ongoing initiatives. So, yeah, Paul, would you like to add something?
Thank you very much for the opportunity, and look forward to helping to grow this whole objective of having energy independence on a global basis here. Look forward to meeting many of you. Thank you again.